right, guys, we're going to talk about trunking. Now, remember our command. All right. Switch port, okay, on our show command. All right. That is going to give us our information. Now, remember, we had to change our mode, okay, our administrative mode of our port, okay, to access in order for us to actually turn on port security, okay. By default, on some platforms, dynamic auto is what it's set to, okay. Now, there's a reason for that, okay. Ideally, we buy switches in order for multiple devices to communicate locally in that location, okay? So right now, I have two routers hooked up, okay? And I have my PC hooked up. I have my files router hooked up to my other switch, which carries those MAC addresses over to here, okay? Now, ideally though, our switch fills up. All 24 ports or 48 ports are filled up. All right, we need to add another switch to our domain, okay, or to our infrastructure. All right. Now, remember, domain means area. Now, from a Microsoft perspective, okay, you think of domains because of domain controller, but in a domain is anything. In my room, in this house, my domain is this room, okay? As I travel out of my room, I am traveling in the interdomain, okay? Inside this room, where I'm doing my recording right now, this is my intradomain, okay? This is my domain, okay? So, the word is not just used on Microsoft, is what I'm trying to tell you, okay? Now, look at this diagram, okay? And this is our switch 1. And over here is our second switch that we're going to add. Now, ideally, we would like to be able to just plug in a switch, connect a physical cable from switch 2 to switch 1, okay? And then automatically, okay, start plugging devices into switch 2, and the communication between those two devices, okay, is possible, meaning that PC5 over here can now communicate with PC3 without any configuration whatsoever. Now, ideally, as an engineer, you would never do that, okay? You actually configure the switch, all right, make your management decisions. Okay, now when I mean management decisions, remember, you are managing this switch. You are making configuration changes, okay? All right? And you want your switch configured correctly. Now, okay? However, don't have an engineer on your organization. You're just doing things by the hip. Don't know what the hell you're doing. Well, now we can be able to plug in another Cisco switch and they'll be able to communicate, okay? That dynamic auto, what it does is when you plug in another switch to another switch, now remember, we need a crossover cable unless it has auto DX or whatever it's called. Now, okay, once that's done, because the switch port that you connect to is dynamic auto, okay, what it will do is it'll automatically turn on trunking, okay, all right, and as you can see here, negotiation of trunking is on, okay, all right, so if we say okay, CFAO 24 has negotiated automatically as a trunk port. that means going from 24 to 24. Okay, see, 24, 24. Okay, my negotiation of a trunk has happened over here. Now, because it's set in an auto configuration of a trunk automatically, all right, that means this switch and the other switch has to negotiate the parameters of that trunk. Okay, this is a trunk port here on this switch because the other switch negotiated and came to an agreement of the parameters of the trunk. Okay, regardless of what those are. One of the parameters is encapsulation, 802.1q. Okay, this is a trunking protocol. All right, this is an industry standard. All right, so Cisco will be able to set up trunks like with a Juniper that will also use 802.1q. All right, so now, all right, and remember everything that I teach you. Check your own research. Question everything I say. Okay, so you go and do your research to find out if 802.1q is a industry standard. Okay, so now, and I want you to do this all the way across the board. This is how you learn. This is how you question. Okay, now if I say something incorrectly, you're going to come and you're going to make a comment and saying that's not the research I found. You're going to challenge me, and then I am going to go out and do my own research and come back and says, you know what, you're right, my bad. Okay, this is your responsibility as you're going through and becoming a master in your field. Okay, as my colleague, it is your responsibility to tell me when I'm wrong or why something won't work. Okay, all right, and instead of getting upset with you, the appreciation that I'm going to have for you is going to soar beyond comprehension. Okay? All right? This is what we do for each other. We look out for each other. Okay? All right? Now, the concept of trunking is this. All right? Locally on the switch, you have configured each port, okay, in its own VLAN. Whether each port's in a separate VLAN or multiple ports are in one VLAN, blah, 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 blah. Each one of these switches has two VLANs, blue and green. Okay? A trunk port is a member of all VLANs. Okay? And the reason why that is because what we want to do is, with the 802.q protocol, all right, what that does is it communicates with its FAO24 port and the other FAO24 port, okay, and traffic that's in a particular VLAN, as it goes down FAO24, it's going to tag that traffic with its VLAN ID. So when switch 2 gets it on its FAO24, it knows that that traffic tagged with VLAN green only goes to the ports that are in VLAN green or VLAN 10 or whatever. Okay? All right? These two ports have to be on the same protocol, 802.1q. Okay? Now, if they're not, there's no traffic being moved over. They can't communicate. That's where the auto aspect comes in. Okay? So we can't make port security decisions on a port that is in auto mode because it could automatically become a trunk and port security won't apply. Okay? All right? So, now, that I'm not saying that's not the case, but you saw what happened when we changed it to mode access. Those MAC addresses didn't come over that port at all, okay? So we saw that failure, which is actually something that was done by mistake, but I'm glad it did. It actually brought up a very good point. All right. So, Cisco's proprietary, I think it's ISL. I can't even remember. Anyway, I don't even think they even do that anymore. Let's go take a look. Yeah, ISL. Okay. All right. I don't think you're going to see ISL on newer switches, but I could be wrong. Okay. All right. Okay. So right now we're set on .1Q. Now we're set on .1Q because of the negotiation. Okay. All right. Now during the negotiation, it chose .1Q as its encapsulation, not ISL. Okay. All right. If the other port was configured as ISL, it would have negotiated ISL encapsulation. Okay, but by default, if both ports could actually do .1Q, okay, let's do .1Q. All right, does that make sense? Okay, this VLAN tagging information is very important now. Okay, when I changed that mode to access, okay, the port went amber. All right, because what was happening was you have another port that's trying to negotiate a trunk, okay, and this port is access. All right, they're not communicating the same language, so it goes in error mode, which is amber. Okay, all right, you still saw the port was up and the protocol was up, but no communication was going back and forth because of the amber light. Okay, all right, which obviously when the port is working correctly, it is green. Now, eventually I'm going to get a camera and go back to the old style that I used to do to let you see that stuff. However, okay, these are the things that are kind of missed in most training. Things like this. All right? I can do switch after switch and have 10 switches here. And every port from switch to switch, that link, if I want VLAN traffic to move down to all the other switches, needs to be a trunk so that traffic can be tagged and carried on into its same VLAN down the path of the switches. Now, what if I went onto the switch port, okay, and didn't have auto negotiation on, or put it in a particular VLAN and not make it a point trunk? Hold on. Switch port. No. Yeah, that's what I want. Okay. I'm gonna have to revisit that. Because I believe there was something like no negotiate, and maybe I'm confusing that command. So we'll let that go for a second. Okay, not really important anyway. All right. So if I was able to put this particular port, all right, let's say in VLAN 30, okay, all right, and this trunk here was tagging the information. Well, this is not a trunk port. What happens to that? Data gets dropped. It goes no farther. Okay, now, let's bring up Visio here. Alright, looks like I'm going to have to get a subscription for Office 365, which is fine with me. All right, so let's go to network, symbols, and where is my normals? Oh, there it is. All right, let's bring you over. Let's bring you here. And let us line, boom. Let's bring it over up here. Okay, now let's do some labeling here. Come on. All right, then let's go ahead and fill this in. And let's make it my favorite color, green. All right, let's bring you here. And let's copy you here. Okay, now, this, no more text. Ooh, wrong key. That was weird. Okay, so now, FA000 on this one, which will be switch 1. This will be switch 2. Okay? FA01, okay, is in VLAN 20. And over here is in VLAN 20. Okay? So, but they're access ports. They're not trunk ports. That means anything that goes out FA01 is going to be in VLAN 20, but this is not a trunk port. So as the traffic goes in this direction, hold on. I have to figure out how to do this. There we go. I gotta find another way to do this. It's up here somewhere. I just got to find it. There it is. When traffic is going this way, I need you to understand something. Okay? It's not going to be in VLAN 20 as the data is going across or egress outside this port. However, if data is coming into switch 1, okay, in this direction, all right, yeah, I know it's crooked. Let's see if we can straighten this up a little bit. Come on. All right, now, it still doesn't match, but it doesn't matter, okay? So now, if traffic is coming into switch 1 on FA001, okay, that traffic, all traffic coming in FA01 is going to be inserted into VLAN 20. As it goes from switch to switch, going across trunk links, it's going to maintain that VLAN 20 isolation. However, this is not a trunk link, okay? This bad boy here, ooh, did I not do that right? Oh, no, I didn't. This link here, okay, is not a trunk link. So as data exits out of this port, okay, whatever VLAN it is in gets removed as it exits out the port. Okay? We can only keep something in a VLAN on trunk links that have been configured as trunks. Okay? You can have one side of it configured as trunk and another side not configured as trunk, but that's not a trunk link. Okay? They're not talking the same language. So as traffic is tagged here on this side, goes across the link, this port is not a trunk link or configured as one, has no idea how to read tagged information. So it gets dropped. Now, I want you to take a look at this. If it's only put in a VLAN with ingress traffic, I want to show you something. Okay, this particular port here is in VLAN 20. As the data exits out and it's not a trunk link, that tag gets removed, or that data is no longer in VLAN 20 as it egresses. Okay, and now, since this port is configured as VLAN 30, what you have done now, okay, which this is a engineer's mistake. This is a configuration mistake, okay? What you have done is you have allowed VLAN 20 traffic to communicate with VLAN 30. This is called VLAN bleeding, okay? And as you get more and more understanding of VLAN traffic, okay, and start configuring things in a wrong fashion, this VLAN bleeding can be detrimental. All right? Yeah, no, I said that wrong. It can also cause headaches, havoc, and non-compliance to security guidelines. Okay? This is a no-no, but very easily to do. Okay? So watch out for your VLAN bleeding. Okay? All right? Whatever you configure one side of the trunk on switch 1, switch 2 needs to be configured the same in theory. Okay? So copy your configs and paste them, or put them in Notepad and paste them on both. Shut down your ports, okay, before doing the configuration, all right? Or just let the auto aspect of it just do its thing, okay? All right? I, as an engineer, do not like auto, okay? From my perspective, anything set to auto is setting it up to automatically fail, okay? Some people say you setting things to auto is something you auto not do, okay? Regardless, okay? Having negotiations works in some aspects, like me plugging in my PC, okay? There is a negotiation going from my PC network card to my network card on my switch on my router, okay? And one of those things is capabilities. All right? Sorry about blowing the nose, but I can't help it. So now, let's go back to here. Show interface FA01 capabilities. Okay? Great command. All right? Because it's going to tell you our speed modes, which is auto. Okay? Because with auto, regardless of how the other port is set up on another network card, if I set that network card to 10 on my PC, plug it into this switch port, okay, and it's set to auto, it's automatically going to go down to 10 megabits per second. Okay? All right? Same with the half duplex full duplex and auto. If it's set to auto, great, okay, because it will negotiate half of full duplex, okay. It tells me my capabilities of trunking types, 802.1q or ISL, okay. All right, non-negotiate. That was the command I was looking for. See, I told you I would come out with it. All right, non-negotiate means don't negotiate a trunk. Okay, we got desirable, we got on, and we got off. Okay, all right. So we got our flow control. All right, we got it off or on or desirable. Okay, all right. We got our QoS scheduling. All right. We have our cost rewrite and our toss rewrites. All right. None of these things you understand, and I get that, but just letting you know that this command is very powerful. Okay, something that you're not going to really learn in a regular CCNA course. Okay, but like I said, we're not doing that. We're we're going through these things in a pretty good detail. All right, so now, and keep in mind, everything that we're covering is really just basic stuff. Okay, now 802.1q. All right, this is the method of tagging packets with a VLAN ID as we go across the trunk link. All right, now one of the things I need you to understand. It is human nature, okay, to think of this switch and this switch as a whole unit. And a lot of people do this, okay? They look at it from end to end as a working mechanism, okay? I don't do that, all right? Doesn't mean that I can't do that, all right? Especially when we're talking about something like multicast, all right? But even with multicast, I look at these devices communicating, but they're separate entities, okay? Switch 1 doesn't communicate with switch 2. All switch 1 does is send information out FAL1, okay? Because that's its job. Switch 2 is going to get it on FAL1, okay? And based on the information it gets, it will send information back out FAL1, but together, separately, these devices are just doing their job. Traffic comes in, switch it out to a port that the traffic goes out. Okay? It has no way of saying to switch 2, hey, guess what? I need you to do this because this stuff isn't working. So go ahead and make these changes. No. All it knows is it responds to data coming in by sending data out. It does its job. If you look at every router and switch as a separate entity, it will give you a real better understanding on how this communication is working. Like a routing protocol. A routing protocol with 20 routers, okay, all right, you add a route to a router and it updates it automatically with the routing protocol to all the other routers, okay? All right, it's not telling the router, hey, okay, I just put this router here, now you need to put this in your, no. But what will happen is it'll send out an update. Its job is done. Okay, done. Now you go over to the other router and look to see if it's receiving that update. Oh, it is. Well, why isn't it in the table? I don't see that route in the table. Okay. Oh, it's being blocked by an access list. Okay. Or something else is blocking it. Okay. All right. Maybe I have a better route in there that's killing it. Okay. Maybe it's not in the routing table because there's a connected device on that subnet. Okay, and you're looking at from the you're looking for the routing protocol perspective and still looking at the connected devices perspective. Does that make sense? Okay. All right. The other router's got the update. Okay. All right. But the original router that you add the data to, or the route to, its job is already done. Okay? Once it sends out that update, it's done its job. It has no idea if the other routers got that route or not, or updated the table. It has no concept, no ability to do that. Where you and I could say, hey, I just added this route to my table, man. Go ahead and put this in your table. Okay? You and I can communicate like that. You and I can make choices as a human being. These are computers. They don't have that power. The only power that they have is to respond to information that comes up. Based on how they respond is based on how the code in the operating system is done. Okay? So if you go into a 100 device network and look at every device as a separate entity, your troubleshooting skills will soar in a direction that most people don't. Because when they look at something like multicast, okay, they look at every device being part of a whole. And that's not the case. It's every device being an individual, okay, and making sure you go to each device, making sure they're doing their job, sending the information out, and sending out the right information. You're done with that device. Now let's move on to the next one. And eventually you're going to find one of those devices, even though it's getting the information on the update, or the update's being blocked somewhere down the path. Okay, you're going to find it because you're going to find that one device that's not getting the update, or is not responding to the update like it should be. Okay, looking at it from a device by device entity. Okay, it took me years to figure this out. Okay, and once I made that switch, okay, troubleshooting was a lot more powerful. Okay, all right, now go back here. Okay, now native VLAN. Okay, native VLAN is an interesting thing. So let's go in here. Let's see if I can remember the command to actually see that. Show interface trunk. Okay. All right. Port. Now, show interface trunk is going to show you all the trunk ports. Okay. It tells you that my mode is an auto. That means we had an auto negotiation. It tells you the encapsulation is 802.1q. The status is trunking, which is what we love to see. And our native VLAN is 1. Now, let's go back over to here. And let us add another switch here. Okay. Oh, you know what? I was going to say, how did I do this last time? This is going to be a hub. Now remember, a hub is a device, 24 ports, 48 ports, but whatever comes on one port of a hub, everybody else who's connected to that hub gets that data. There is no MAC address recording or anything like that. Okay? So, now. Okay, why are you on top here? Alright, so let's go back over to more shapes. And computers and monitors. Okay. Okay, I did a video on this concept a way back. And I'm trying to figure out how I did it. I think this was plugged up here. And I'm putting on my thinking cap, so bear with me. Okay, first of all, let's get this moved over here. Oops, come on. All right. Okay, now. What happened there? Wow, you're being stubborn, aren't you? Okay, now. This is in VLAN 20. Man, you're being really stubborn. Because I keep hitting the wrong key. That's the problem. Yeah, I'm sorry. I'm tapping my foot here. Kind of a OCD thing going on. All right, so now. If we analyze this data here, because I still don't think I have it set up correctly. VLAN 20, VLAN 20. Oh, wait a minute, I think I just got it. Hold on. Okay, now. You know what? That's not correct. Okay, now, if I have native VLAN 1 on this side and native VLAN 5 on this side, okay, on this switch, you're going to get a constant annoying message in your logs. Native VLAN mismatch. Okay? What native VLAN means is if traffic is going across the trunk, every tag traffic needs to correspond to its proper VLAN that it's tagged with. However, untagged traffic will automatically go to the native VLAN. Okay? Now, this is correct. And we have to do this like this here. Now, I remember when I first did this video, and you know what? I'm going to upload it too, because I'm sure I have a copy of it. All right? Okay? Because I might be doing this wrong. All right? And I'm going to upload it right after this video that I'm doing now gets rendered. Maybe even before. Okay? So now, this is in VLAN 1. Okay? And we're even going to come up here. Okay, so in VLAN 1, we have a 1.5 address. In VLAN 20, we got a 20.5 address. Okay, now, because we're connected to a hub, there's no way to connect the hub to an actual trunk port because it has no ability to be configured as a trunk port. Okay, all right, it does not have the power that a switch has. All right, all it does is takes information on one port and shares it across the rest of them. All right, now, that means, okay, as traffic is going from this PC, PC2, to the hub, into here, okay, all right, that traffic is in VLAN 20 because of the port here, okay? And that means these have to go bye-bye. Okay? Now, if I do this and take that out of VLAN 20, it's going to be defaulted into VLAN 1. Okay? That traffic VLAN 1 does not get tagged. Okay? That comes across. And that is the information that I tried to prove in one of my videos. Alright? And it wasn't something that was easy to do. Okay? Because the native VLAN never gets tagged. In theory, this is what you're told by Cisco. But how do I prove it? Alright? And what if traffic comes across the port that's not tagged? Guess what? Okay? Yeah. And I'm sure I've got this set up incorrectly, but I'm just going to upload that video and we'll do it from there. All right? So now you're starting to see that something like this seems a little bit extra complicated than necessary, but that is how you learn with that complexity. Okay? How do we prove that the native VLAN is untagged? How do we prove this? All right? And we'll show that in the next video. But as far as a concept that, why would you do this? If Cisco tells you it's untagged, it's untagged. Okay? However, there was something that was making me believe that it was tagged. Like in the header information. Okay? Alright? So, in the 802.1 spot, it still showed VLAN 1 as being tagged from my perspective. So, that's my point. I'm questioning Cisco. And I'm going to prove Cisco wrong or prove me wrong. Either way, I'm going to learn something. And that's what you should be doing with me. Okay? Or any instructor. Alright? Set the labs up to prove or disprove or set the record straight from your perspective. Okay? I can honestly tell you that the traffic's untagged because of the lab that I'm going to upload. And you're going to see it too. Okay? Alright? So, our trunking protocol from Cisco is ISL. 802.1q is industry standard. Okay? Alright? Now, pretty much this is what we discussed just now, right? Okay? Alright? And we also have our voice VLAN. Okay? And all this is doing is showing you that a phone here is going to be sending out particular types of data with particular types of headers. Okay? Any types of data in the voice header information, okay, is going to go into the switch that is configured as a voice VLAN. And that voice VLAN traffic will be tagged as voice traffic as it goes across the trunk. Okay? Alright? Now from here, we're going to end this video. Be strong, be determined, be Cisco. I'll see you guys on the next one.